Okay, so we need to represent a trigonometry problem in 3 dimensions. So the first thing we'll do is think about how the x and y axes, as you'll normally see them on GeoGebra, relate to our diagram. I'm going to represent them to be laying flat on the ground. So our y-axis becomes the north direction, our x-axis comes the east-west direction. So as a starting point, I'm going to label point A to be at the origin. And we need to add in a north line. Once we get to working in 3 dimensions, it's really important we know exactly where that north direction is. Now I'm going to use a vector to represent that. So I'm just going to draw a vector from A along the y-axis. Now that represents our north line, so instead of calling that B, I'm going to rename that to be north. Enter. And that looks much better already. So now we need to create a bearing of 240 degrees. So if you go to your tools, you see something representing an angle, and we want an angle with a given size. So if we want this bearing to be from A, we need to first click on the dot at north, then A, then you enter the angle size. So I've entered 240. We want that to go in a clockwise direction for our true bearings, and hit OK. So that's given us one point that lies on a bearing of 240 degrees from A. But I need to, that's not necessarily the distance that I require. So I'm going to draw a ray from A through that new point. So that north dash point, I'm just going to click on the icon next to that so I can uncheck it. It's something that I don't need in my diagram. I now know the direction of that bearing. Next thing I need to do is work out how far along there Mrs. Ricks walks. So I'm going to use a distance of 20 metres. Your distance may be different to that. There's 2 ways we can do this. One is to create a segment with a given length. This creates a segment on your diagram, then you need to transfer this onto that line. So I'm not going to do that. I'm going to instead construct a circle with the centre at A, and I'm going to set the radius to be 20 units. Initially it doesn't look like there's anything there, but that's only due to the scale that we can see on the screen at the moment. So if I go back and select the cursor tool before I try to do any zooming in or out, it's going to make life a bit easier. So now I'm going to go and create a point on the point of intersection of the circle and the ray that we drew earlier. And that circle, that point B, as it's currently labelled, is a point that's on a bearing of 240 degrees from A and is a length of 25 units from A, so it's where Mrs. Ricks finishes up. So we'll go and rename that point now. I believe in the question it says to name that point P, so we'll do exactly the same thing. Make sure everything relates and enter, and it's relabelled accordingly. I don't need to see that circle anymore, so I'm going to uncheck that. And if I draw in a line segment from A to P, I now don't need to see the entire ray, so I can uncheck that as well. It just makes the diagram a little bit neater. And that's a process that I'll do a few times throughout this. One thing I should do while I'm here is that I really do, that's something important to the answering the questions in the diagram. So we'll label that distance. I'll get it to measure the distance of AP. Just click on that line there. It's 20 units. Obviously yours will be different to that. Because I'm wanting to construct a rectangular prism that shows this bearing and the angle of elevation, AP will be the diagonal of the base of that prism. So I'm going to construct some vertical and horizontal lines through P that will end up forming edges of that prism. So in our tools, there's the option to construct a parallel line. So I want to construct a parallel line through P. So I'll click on P and click somewhere on the y-axis. I've got a line parallel to the y-axis. And we can do the same to construct a horizontal line to the x-axis and click somewhere on the x-axis. What I might do at this stage, so we can differentiate the rectangle that's on the base from any of the other rectangles that are in the diagram, I'm going to construct a polygon. And I'm going to click on A. The point of intersection of the vertical line with the x-axis, the point P, the point of intersection with the y-axis, and then back to A again. And that's now just giving me a shaded rectangle that represents the base. Might be helpful when it comes to viewing in the 3 dimensions. Now, because I've got that polygon drawn in, I don't need to see the lines, the vertical and horizontal lines that I constructed before. So if we can find them on our list of objects, we can uncheck the 2 lines that we've got drawn. You can see just the information that we need. I've got a random point D over there, so I'll just hide that. So now I think we're ready to transform into the 3rd dimension. Now, depending on which version of GeoGebra you're using, this is going to appear quite differently, so it will take a little bit of playing around. Just ask one of your teachers if you need any assistance. So on the right-hand side, we've got a drop-down menu and allows us in the View section to view 3D graphics. And fortunately, mine's come up quite nice because I've already played with this before, but when yours first appears, you may not have a vertical axis showing, you may not have a grid there, you may have X and Y axes shown. So I'll show you how to change those views. Still over on this right-hand toolbar, if you go down to Settings, and on the very right-hand side, you'll see that there are settings for, the second one down is for your, I can't remember, it's for your objects that you've got drawn. The third one down is for your X and Y axes. So on your X axis, you can show the axis or not, and Y axis, that's in your normal graphics view. Then the pyramid there represents our 3D view. So at the moment, I have my X axis showing, my Y axis, excuse me, showing, and my Z axis showing. But I've only shown the positive direction only, because I'm not going below ground level in this problem. If you want to turn the grid on and off, you can do that. Whether it helps you or not, I'm not sure. But certainly in the settings is where you find the options to show those things. Now, at some point I must have hit my undo button because I've got those lines showing again that I hid before. So let's get those off the page. And the point D's reappeared again too. So my next job is to determine the original height above D. Now I'm going to use, in my example, I'm going to plot a point that's 10 meters or 10 units above my starting point. And that's as simple as just clicking on the y-axis. Once you have located that point on your y-axis, if that's not quite right, you can go and see that all we've got to do is just change the coordinates there. Your X and Y coordinates would be on the horizontal plane, and your third ordinate is in the Z axis as it's represented here, or the height axis. And you can just go and adjust that to what's appropriate. So now we need to think about representing our angle of elevation. Now I could use this doing line segments again, but I'm going to go straight to creating a polygon. So this polygon, I'm going to join E to A to P and back to E again. And we should clearly now be able to label in the angle of elevation. So going across to our angle tool, I want to mark an angle of elevation. So now I just click on points like I would normally name an angle. So angle E, P, A. It's not very clear at this stage, that 26.6 degrees on my diagram. So if I go up, and I think it's right at the very top of the angles, on that little drop down menu we can hit settings, and hopefully if I actually clicked on the object before I did that, angle settings, we should on the style be able to adjust its size, which makes it a bit clearer in the diagram. So the last thing I would be doing if this was my assignment is I would be actually completing that rectangular prism. I'd probably also change the colour of that second polygon. So we had triangle down here. If I click on that, excuse me, and click on the settings, if I go into colour, we can change that colour to be whatever is appropriate. Let's go with pink. Okay, so let's complete that rectangle. So I might want to see my X and Y axes to complete the rectangular prisms. So let's go to settings, and in the 3D view, I want to show my X axis, I want to show my Y axis. For some reason, they should have already been shown, but that's okay. So we need some rays that go, excuse me, we need some perpendicular and parallel lines. So through E, I want a line parallel to the Y-axis. Let me try that again. Through E, I want a line parallel to the Y-axis. And through C, I want a line parallel to the vertical axis. And I can mark a point of intersection there. So, in fact, I'll go and draw in the segment EF and FC, so I can then hide that ray. So I can hide the line. And we go and complete that, continue doing that process. So once you've got your final rectangular prism drawn, so I'm still missing a few edges from mine, but you can see it's only a repetition of the same procedures. I would probably hide all the information that's not relevant. So I would go back to my settings, and in the 3-dimensional pyramid settings, I'm going to hide my Y-axis, I'm going to hide my X-axis, and I've got those pesky lines back again. Hopefully your version isn't doing this. And what you really then need to do is to get a rotation on, and again my X and Y axes are appearing, but you just need to get the best rotation so that you can see all the relevant information, and that's what we want to be able to see in your diagram when you present it to us. So one additional thing, I haven't labelled the height of the drone above point A. I haven't relabelled the point E to whatever the drone said in the question, whatever the label said in the question. So there's still things that need to be done, but I think I've gone through all the steps or all the procedures that need to happen. Best of luck.